Hello, class. Today we'll be talking about Chapter 5. So, first starting off, we'll be looking at 5.1, which we'll be talking about angles. So, some basic terminology we're going to go over. We're going to look at degree measures, and we also will look at standard position and coterminal angles. So, some basic terminology. Two distinct points determine a line AB. Then we have a line segment AB is a portion of a line between A and B, including the points A and B. Then we have a ray is a portion of the line that has the start point of A and continues through or on pass through B past B. All right, now let's look at this. So the first thing is a line because we have what? We have it going through both A and B. So you have no stopping points. The line segment has stopping points on both ends. So it goes from A to B. The ray has a starting point A and it goes through B. So it's continuous going through B. So that's how you figure out what's the difference between a line segment, and a ray. So an angle consists of two rays in a plane with a common endpoint. Now, it says the two rays are the sides of the what? Angle. And it says the common endpoint is called the vertex. So where both rays come together is called the vertex. It says an angle's measure is what? Generated by rotating about the what? Vertex. So basically the initial side is where you start at. Then where it rotates at, that is called your terminal side. So make sure you understand where your initial side would be what? Horizontal. And your vertical side will either be slant, vertical, or it could be obtuse or whatever else. So it makes different angles. And we'll talk about that, as we get there. Now, to get a positive angle, you have to do what? Rotate counterclockwise from your initial point or your initial side. To get a negative angle, you have to go what? Clockwise to get a negative angle from your initial point. So that means your what? Your initial point rotated clockwise to get to your terminal point for a positive angle. Then your what? Your initial side rotated to get to your terminal side clockwise for the negative value. The first for positive is counterclockwise, for negative is clockwise. So degree measures. The most common unit for degree angle measuring angles is degree. So a complete rotation of a ray gives you what? A measurement of 360 degrees, like a circle, right? So you start at a point, then you come all the way back around till you get back to that same point. Now, 1/360 is a complete rotation that gives you an angle whose measure is 1 degree. So it says 1/360 is a complete rotation. All right? So you got to keep that in mind. What it did was it's saying one rotation, right, is equal to 360 degrees. But if I wanted to get 1 degree, it'll equal what? 1/360 rotation. 1/360 of a rotation. So just keep that in mind. That's how they got that. Now, let's look at these angles. We have an acute angle, which the angle results in what? Between 0 and 90. We have a 90-degree angle, which the angle would be 90 degrees. We have obtuse, which is the angle in between 90 and 180. Then we have a straight line, which theta is equal to what? 180. So we got a acute, right angle, obtuse, and we have a straight angle. Now, let's look at this. So, if we look right here, it says for an angle measuring 40 degrees, find its complement and supplement. Now, when we talk about complementary angles, we're talking about angles that add up to be what? 90 degrees. When we talk about supplementary angles, we talk about angles that add up to be 180 degrees. So, for part A, we're going to have 90 degrees minus your 40 degrees, which you was given, and that's just going to give us 50 degrees. That is the complement. Now, for the second part, we're going to have what? 180 degrees minus the 40 degrees, and that's going to give us 140 degrees. Those are supplementary and complementary angles. So the complement of 40 degrees is what? 50 degrees. And the supplement of 40 degrees is 140 degrees. Now, you might have seen this before, but it's just a refresher of what to do. Now, let's look at it at a more advanced level. So here, if we look at it, it gives us what? It says find the measurement of each marked angle. So basically, we have two angles that make up what? 90 degrees. So we have 6x plus 3x is equal to what? 90. Because they both of the angles add up to be 90 degrees. Therefore, I got 9x is equal to 90 degrees. So it'll be what? X is just equal to what? 90 divided by 9, which gives me 10. Now, we're not done because we still need to find what are the degrees for both. So we basically have 6 times 10, which gives us 60 degrees. Then we have 3 times 10, which gives us what? 30 degrees. So just make sure when you're doing this, you have to finish it and tell me what the actual measurements of the angles are. Now, how did I know it was 90 degrees? It's a box right here. Usually when that box is there like that, it is a 90-degree angle. Anytime you see the box like that, it's a 90-degree angle. Make sure if you have any questions about this, you make sure you contact me through Microsoft Teams or you send me an email. Quickest way is Microsoft Teams because we can either talk or I can, help you through a problem. So let's look at this problem. So now this one's a little different. We basically have what? These are supplementary angles. So it adds up to be 180 instead of 90. So basically we have what? We have 4x plus 6x is equal to 180. Now, we know that this is just what? 10x is equal to 180. So we have x is equal to 180 divided by 10, which gives me what? 18. Now, we know we're not finished because that's what x is. So now we want to go back in and say we got what? We got 4 times 18. Now, when we multiply 4 times 18, we get 72. Then we have what? 6 times 18. And that gives me what? 108 degrees. Now, let's say you didn't want to do that. You could have just took that first one and subtracted it from 108 and got 108, right? So just keep that in mind. So just keep that in mind because you can still do that. So make sure if you have any questions, let me know. So let's look at this. We have degrees, minutes, and seconds. 1 minute is equal to 1 over 60 of a degree. So 1 minute is equal to 1 over 1/60th of a degree. Or you can say 60 minutes is equal to what? 1 degree. So what's missing here is 1 degree. So in 60 minutes, we have 1 degree. Now, 1 second is 1/60th of a minute, right? So 1 second is 1/60th of a minute. So that equals what? 1 over 3,600. 1 over 3,600 degrees. Or you can say we got 60 seconds in 1 minute. So keep that in mind. Or, in another thing that we could actually write, we have what? 3,600 seconds in 1 degree. Right? So keep that in mind. It's just another conversion to help you do these problems. So let's look at some. So now we're going to add these things. So the way that I like to add these, I like to put them underneath each other, like top and bottom, like regular. So I got 51 degrees, 29 minutes. Then I got 32 degrees and 46 minutes. Now, you only add minutes to minutes, degrees to degrees. So keep that in mind. So when we add this, we're going to get 75 here, minutes. Then the degrees going to be where the degree is. Then we'll get what? 83. Now, when you do problems like this, you got to make sure you understand what's going on. Now, this is not the answer because we have 75 minutes. All right? So keep that in mind. Now, how many seconds is in a minute? Or how many degrees, or how we can say it this way. How many minutes is in 1 degree? We can say it that way. We know that we have 60 minutes is equal to what? 1 degree. Therefore, in this case, if we have 75 minutes, that's equal to what? 1 degree and what? 15 minutes. So therefore, we're just going to say that this is going to be what? 84 degrees and what? 15 minutes. Because we just basically took what we have here and added it to what we already had, all right? Because we basically just converted that 75, which is this, into what? 1 degree and 15 minutes, because we know 60 minutes makes 1 degree. All righty. Let's look at this one. So in this problem, we have 90 degrees minus 73 degrees and 12 minutes. Now, let's look at this. Now, you probably sitting like, okay, we got a whole degree. How can I work this? Now, since we know that 60 minutes is equal to 1 degree, we're going to manipulate it. So if I got 90 degrees, I can rewrite it as 89 degrees and 60 minutes. Because we know that what? 60 minutes is equal to what? 1 degree. So that'll give us our whole 90. So when we rewrite this, so we got 89 degrees and 60 minutes. Then we're going to subtract this. So we got 73 degrees and 12 minutes. And we're going to subtract them. So, and when we subtract them, we're going to get what? We will get 48 minutes. And then in our degrees, we get 16. So, our answer would be 16 degrees and 48 minutes. Just wanted to give you a variety of these things so you can remember what you're actually doing. Let's look. Now let's look at this. Now this is converting between decimal degrees and degrees, minutes, and seconds. So from decimal to degrees and degrees to decimal. All right, to DMS. So let's look at this. Now, to do a problem like this, so we're going to have, now, your degrees always stay the same. So you'll have your degrees stay the same. Now is plus. Now we have 0.8, which is just 8. All right, keep that in mind. It ain't 0.08, it's 8. So we go ahead and divide this by your 1/60. Then plus your 14 over your what? 3,600. Now, remember, because it's what? If you do like the conversions, we know that we're trying to change this into degrees, right? A full degree. So we're going to put it in a DMS. So when we do this, we're going to get 74 degrees. And then that's going to get plus. Now, when I write this, all right, make sure you go through the steps of this. So really, if you really want to do this, you could just go ahead and put in the calculator and you'll get 74.137. And that's in degrees. Because you'll get what? 0.1333 degrees plus your 0.0039 degrees plus your 74. Then that's how you would get that when you add together and you do what? You gotta add them together. Then you have to make sure you simplify it and reduce. So make sure when you're doing these, you know exactly what you're doing. Now, this goes back to that slide previously when we talked about how many degrees is in a second, how many different degrees we got. We got 1 degree is equal to, 60 minutes, and 1 degree is equal to what? 3,600 seconds. So we're using this because this is going to be our what? That's our minute space. And this is our seconds. So we had to get rid of that conversion, right? So that's why we basically multiply by its unit fraction. All right. Let's do this one. So with this problem, we're going the other direction. Now, when we do this problem, you're going to see it's going to be kind of interesting how we do it. Now, the degree is always stay the same, so you leave the degree out of it. So that's 34 degrees. Now let's look at this. Now I'm gonna leave the degree over here because degree is not to be messed with. So we got 0.17. Now you have to multiply that times 60. So you multiply it times 60 minutes, and when you multiply it times 60 minutes. You'll get 49.1 0.02 minutes. Now, the whole number of this is what you're going to use for your minutes. So you got 49. Now, the end part, this part right here, we're going to do this same process again, 0.02, and we're going to multiply that times 60. When we multiply that times 60, and we're going to multiply that times 60 minutes, 60 seconds, of course. So that's going to be seconds. And we multiply that, it's going to be 1.2 seconds. Now, when we multiply that, now we do what? We round. So let's just go round off to 1. So it'll just be 1 second. So we got 34 degrees, 49 minutes, and 1 second. So basically, you keep the whole number as is. If you got 34 point whatever, 34 is your whole degree. Then you do what? You mess with the decimal. So that's how you get degrees. We get minutes a second by messing with the decimal because it's not a full degree. So just keep that in mind. So let's look at this. So we have standard position. It says an angle in standard position if its vertex is at the origin. Now, if you don't remember what the origin is, it's the point at 0, 0. All right? And its initial size lies on the what? Positive x-axis. All right? So the positive x-axis, as you see, is the horizontal axis on the right side. Now, if we look at the terminal side, we have what? We have different quadrants. We have quadrant 1, we have quadrant 2, we got quadrant 3, quadrant 4. It can be any one of those. So just keep that in mind. Quadrantal angles. Angles in standard position whose terminal side, all right, for along the x-axis or y-axis, such as with the angle of 90 degrees, 180, 270, and so on, is called a quadrantal. So basically, the terminal side lands on the what? Quadrant. It lies on the line. So either the 90 degrees, the 180 degrees, the 270, 360, and so on. So coterminal angles. A complete rotation of a ray results in the measures of 360 degrees. By continuing the rotation, angles of measurements larger than 360 can be produced. Such angles are called coterminal angles. So basically, by adding 360 degrees, you can find what the angle shares if you do a complete rotation of 360. Just like we look at 60 degrees, our positive coterminal angle would be what? 420. If you add 360 to it, you'll get what? 420. Now, if we were to look at 110, we know that if we go around, we add 360 to it, then we add 360 again. That's how we get it. We add 360 twice, so we went around twice. So that's our second positive coterminal angle. All right? So keep that in mind. Now, it says find the angle least positive measure coterminal angle. All right? So with this, we have to actually just look at what we have. So let's look at what we have. So the first thing I like to do is draw an axis. So my thought is this. Now, me personally, what I usually do, I like to do what? Divide by 360. Honestly, that's what I usually do. I like to divide it by 360. So if I do 908 divided by 360 degrees, that's what gives me, and I'm going to put it in the calculator. So it's 908 divided by 360. Which is going to give me 2 point. Let me make sure I put that in there. Yeah. 3.22 repeating. All right. That's what that gives me. Now, I know that I have 2 complete rotations. So I know that what? I go around to 360. I know I go around again to 720. Now I know that if I got 2 rotations, I got 908, sorry, minus 720, and that should tell me what I have left, right? So I have 908 minus 720, and that gives me 188 degrees. So therefore, I would be able to go around 180 and then 8 more degrees. So it'll be 188 degrees. So just keep that in mind. So the least positive coterminal angle is 188 degrees. So let's look at this problem. It said find the least positive coterminal angle. Now, with this, I'm going to go ahead and draw my plane. And I know from this way, I'm actually going this direction. And I don't even make it to the line, right? So therefore, I need to go in another way. So I'm going to go to the positive direction. So if I want to go to the positive direction, all right, all I got to do is do what? Now, it'll be what? 360 degrees minus my 75 degrees, right? Because I'm already negative. And that should give me what? 285 degrees. So this would be 285 degrees. Then this is my negative 75 degrees. So it's 285 degrees. That's my least positive coterminal angle. So let's keep looking. So it says find the least positive measures coterminal angle with 800, negative 800. Now, I'm about to do the same exact thing. So I draw my plane. I mean, in the whole point of drawing this is the X, this is the Y, of course. Now, we know that if I go around this is 360, go around again, it is what? 720. So if I got 720, negative 720, I need to go how many more? 80 more. So I know that technically from, and I'm about to, from here to here, that's negative 80 degrees. From there to there, that's negative 80 degrees, right? Because I know going all the way around was 720, then I had to add 80 more to get to the 800. So I know that this is what, negative 80 degrees. So, therefore, I know all I got to do is do what? 360 plus a negative 80. And that's going to give me what? A 280, right? 280 degrees. $280 degrees. Now, you know when I'm talking about that I'm going around and I'm actually getting this demand. So that's where my 280 degrees comes from. So just keep that in mind. So let's look. So it says what? To find expressions that would generate all angles coterminal to the given angles, add integer multiples of 360. Basically what I've already been doing. All right. For an example, the expression for all angles coterminal with 60 is what? 60 degrees plus n times what? 360. So let's look at a chart of that. So if I wanted to find the least positive coterminal angle, I would just put in 1. It would give me 420. If I wanted to find the second, all right, if I wanted to find 2 coterminal angles, I would put 2 in there, then I would get 720. Now let's say if I wanted to find a negative coterminal angle, I would just put -1 in there. And then I would go so on, -2, and keep on going. All right? So keep that in mind. 0 would just be itself. All right? So you don't want to use 0. We either use 1, 2, or -1 or -2. -1, -2 is when you're trying to find the negative case. 1 and 2 is when you're trying to find the positive case. So keep that in mind. So let's look at this problem. So it says CD players always spin at the same speed. It says suppose a player makes 480 revolutions per minute. It says through how many degrees will a point on the edge of the CD make in 2 seconds? So if we know that it revolves 480 times per minute. So we basically have what? 480 over what? 60. Right? Which gives us what? It gives us 8 times per second. 8 times per second. All right? So if it's per minute, then I change it to seconds. It's 8 times per second because we're going to deal with seconds. So in 2 seconds, we have to do what? We have 2 times the 8, and that should give us 16. So it what? 16 times. So it goes through 16 times. So each revolution is what? 360, because it goes all the way around. So at the point of the edge, we basically have what? 16 times what? 360. because it goes through 16 times. So go all the way around to the same point 16 times. So going through that, it should what? It should do what? 5,760 degrees in 2 seconds. And that's your answer. So just understanding what it's actually asking you really makes a difference. So it gives you some real important stuff right here. It gives you it in minutes. It tells you how many revolutions per minute, but it don't tell you how many revolutions per second. So basically what we did was we changed the minutes into seconds, and then that's what we looked at. So just keep that in mind. So if you have any questions about any of these problems, just let me know. Send me a message through Microsoft Teams. Remember that you can pause these at any time. You can make sure you understand anything that I'm doing. I mean, just keep in mind of that.